In this video we'll be going through the SQL injection vulnerabilities on DVWA. So as usual we have our security level set to low to begin with, and we have a box asking us for a user ID. You can see I've already been playing around with this. We can send it 1 or send it 2 and get our user IDs. Have some good resources here as well. Another good resource is the Portswigger SQL injection. They have a cheat sheet here, and they have a lot of materials and labs as well to check out. So I'd recommend that. There's no point in me sitting and showing and reading through all that, because you're obviously here to watch the video. So let me check out first of all the help and see what's our objective. So our objective is there are 5 users in the database with IDs from 1 to 5. Our mission is to steal their passwords via SQLi. And you can see the low level here, which is the one we're doing at the moment, uses raw input that is directly controlled by the attacker. All they need to do is escape the query, and then they're able to execute any SQL query they wish. So let's take a look at the source code as well before we have a play around with this. Try and see where the vulnerability is here. Okay, so it takes in an ID here in the GET request, and we have an SQL query. Select first name and last name from users where the user ID equals the parameter we provide. So the issue here is that there's no validation on the parameter that we provide, which means if we're able to insert a quote here, we can actually add more to we can inject some code into this SQL statement. So let me give you an example of what I mean, just to make that clearer. Just open Sublime, and if we were to select first name and last name from where the user ID equals, and then let's say I send in crypto, but if I was to send that in and then insert a quote at the end as well, I'm essentially breaking out of this statement so that I can say now where the user ID equals crypto, or 1 equals 1. And now we've just injected some code into the statement to say that if the user ID equals crypto or 1 equals 1, which it always does, then bring back the first name and last name. So essentially it doesn't matter whether the username equals crypto or not, it's going to bring back everything because we have that 1 equals 1. So let's go and test that out. We'll send, first of all, just send a quote, and you can see we get the error there. There's an error in your SQL syntax because we've inserted the quote there, we didn't add any more code, and we've not closed that off. So let's go back, and instead of sending just a single quote, let's send, so we're going to say if the user ID equals 1, and then we're going to close off that statement, and then we're going to say or if 1 equals 1. And if we submit that, you see we get back everything because the ID, because this condition always holds true. And so we might want to try that again, but we could also then say union select all from password. Okay, that just brought back our first account. Let's go and check out what we have here with the SQL injections here. Do we have union attacks? And we may need to do this to determine the number of columns in the table. Union select. Okay, try that with I commented that out in a different way. Let's try that again. Order by 2. Submit, that's fine. Order by 3. Okay, unknown column. So we've essentially just tried that until we've identified how many columns we have. We have 2 columns because we run that until we get an error. You see there as an example. So we have that. Now let's see. Let's try this. Union select username passwords from users. And just change this to match the MariaDB syntax. Unknown column username in the field list. Let's change that to user. And there we go. We've got union select user password from users, and it's brought us back all of the accounts there, and it actually has the surname as it's returned. Sorry, let's let me grab a copy of that, and let's just do one. So you see here it's returned. It has two columns where it can return data to: first name and surname. So we identified we didn't really need to do the order by to find out how many columns, because we know we have it's returning an admin and a first name and a surname. So whenever we run this and say union select the user, okay, that didn't copy the right command there. 1 second. Union select and it's user, not, or is it just because we're missing? Let me try. No, okay. Union select, we need the hash at the end there. That's just to comment out the rest of the statement, and then we want to just select user. I'll grab a copy of this so we don't lose it again, and submit that. So it's still giving us, it's still returning the first name and the surname column, but it's, instead of actually putting the first name and the surname in there, it's putting in the user and the password from users. And you can see here these are password hashes, so we could go and have a look and see hash ID. And it'll give you an idea. It'll list what possible hashes it would be, probably MD5. So we can maybe look into cracking those as well. So let's do the other difficulties first. Let's go and change the security level to medium. Submit that and go back to the SQL injection. Let's have a look at the help again, and out of interest, let's see what the spoiler was for the first level, for the low level. And yeah, so they passed an ID A and then use a quote to inject into the statement, and then we're saying union select, and yeah, they've put text. Okay, so they've actually used a different, they didn't use the same syntax there for commenting out. Okay, well, the medium anyway, the medium level uses a form of SQL injection protection with the function mySQL real escape string. However, due to SQL query not having quotes around a parameter, this will not fully protect the query from being altered. The text box has been replaced with a predefined drop-down list and uses post to submit the form. Okay, interesting. Let's have a look at the code. Let's maximize this. So you can see this time with the code, we have this post parameter, the ID, and we have the MySQL real escape string, which is gonna escape the strings there. So if we put in a quote, it's gonna put in a backslash before it, so that won't be interpreted in the SQL statement. But the SQL statement itself looks the same. Let's close that down, test this out. So we have, okay, we can submit the user here, and you notice we don't have it in the get request up here, which means we're going to need to go and have a look at this in Burp Suite. Let's go to proxy. We'll grab that request and send it to the repeater. And let's see what we have here. Post, we have the ID, and then submit ID. Let's try and put in the quote and see what we get. Error in your SQL syntax. Find out what matches your. Okay, let's try what we did last time, which was or 1 equals 1. We might need to submit that. Okay, still an error. So the error is probably to do with this quote. But another way we could do this, just what I'll also mention, is we could potentially just say, let's inspect this element. Whereas the ID, we have these different options and the option values. So we could say option 1, actually we want to be or 1 equals 1. Let's grab a copy of that as well, just so we can see what we're putting in there, and let's put it in the text. And now you see we've actually set that to equal that. So if we hit submit, you can see it's actually tried to run the SQL query, and it's given us the error to say this doesn't make any sense. You've sent me a lot of backslashes here. What's going on? So yeah, we need to fix that. And the hint that it gave us was that let's go back here, medium level. However, due to the SQL query not having quotes around the parameter, this will not fully protect it from being altered. So let's go back to the source. Yeah, so the query is different. I didn't look at that properly. Last time we had single quotes around the ID, so we needed to escape the single quotes in order to get into the SQL statement. In this case, we don't even have quotes at all, so it's actually even easier for us. Let's modify this again. Inspect element, and let's change the value and just take out the quote altogether. Or 1 equals 1. Let's just send it like that. Let's submit that. Or 1 equals 1. Okay, let's try it with our union statement. Let's modify that again. And I'm going to set that in here as well, just so we can see it. This is what we're sending off, but we're sending it without the quote at the front of it this time. Okay, please check you have an error. Okay. Oh, we still need our condition in here. So we still need to say we're selecting the ID 1 or 1 equals 1 and then our union. Let's try that. Let's grab a copy of that as well. And there, that's got that back. So we've actually pulled back all of the users and the passwords here as well. Let's go to our burp suite. We had this submit option. Let's just try and submit it here as well. And URL encode that. And you can see that it's brought back all of our hashes there as well. So let's check out the high security. Let's go back to DVWA, set that to high and submit. And let's see what's different this time. Let's go to view our help. And let's check the spoiler for our last level. Yeah, it's just suggesting to do it without the quotes then. And then a high level, this is very similar to the low level, so our first one. However, this time the attacker is inputting the value in a different manner. The input value is being transferred to the vulnerable query via session variables using another page rather than a direct GET request. Okay, let's have a look at the code for that. And this is for high, so we have the session ID is set session ID, okay, and then that's going to be passed in. It's limiting, but we'll be able to comment this out anyway, and we can see that we'll need to use our quotes again. So let's click to change ID, see what happens here, and we have this new page. Okay, let's try and send the union select. Okay, that's union select all. Let me grab the one that we'd used previously, which will set 1 and then a quote and then union select user and password from users and then comment that out. Submit that, and there we go. Okay, so that was very easy. And we now have our credentials again. Let's finally then just go and change this to impossible. Submit that, and let's go back to our SQL injection. We have the user ID. Let's paste that in again. We get nothing back, and let's have a look at the help just to check our high level. It was basically the same, just through a different form. And then impossible level, the queries are now parameterized queries rather than being dynamic. This means the query has been defined by the developer and has distinguished which sections of code and the rest is data. So let's take a look at the source. Okay, and there's an anti-CSRF token here. Okay, we get the ID. Checking to make sure that the ID that was passed in was a number, so a number and nothing but a number, and then you can see here that it's specifying that that's just passed in and treated as a number before it's executed. So that's that all secured. Let's see if we can, as a little bonus exercise, try and crack some of those hashes. So let's go back to DVWA security and just set that back to low for now. Let's go to our SQL injection and let's put in the command to get the hashes. And I'm just going to create a file called hashes. We'll paste these in. One by one. Another thing we could have done is just selected the hash as well to bring that back. Well, I suppose it's gonna print the first names anyway. We couldn't do that. Okay. Oh, okay. The Smithy and admin have the same password, which is password anyway. So let's just skip that one. And there's a few things we can do here. There's a few tools we can use. We can use hashcat, would be the most popular. If we do man hashcat, advanced CPU-based password recovery utility. In fact, the GPU hashcat is a lot faster, but if you're doing this inside a VM, it's not going to be anywhere near as quick. We can also use John. Let's use hashcat first. So we'll do hashcat-h, and you can see here it'll give us some examples. It's quite a powerful tool, so there's a lot you can set up here in terms of like rules and things. You can see here there's a lot of options that we can use. We don't need to worry about too much of that. We're going to be dealing with an MD5, which just a plain MD5 is the mode number 0. So if you go down here and see what does it show us the syntax at the bottom. Let's do hashcat-a0-m0 and then hashes and then our word list. So I'm going to do seclist, passwords, probable top. What do we have here? I'll do probable top 1575. You see, we start to run that. The word list on mask you're using is too small. Okay, well, we got our password ABC123 and then let me in. What did we miss? We missed the 8D one. Okay. Let's have a look at John as well. If you do John-H, you can get up the syntax for this as well. It takes John, options, and then password files. So John -- list, and how do we get the mode here? Okay, John, let's try John mode list. -- list format. Okay. Okay, maybe I should actually read the thing here. What does it say? List formats It says dash dash list formats. Okay, dash dash list equals formats. Did I do something differently there? Oh, format instead of formats I did. Okay, and here's our list of formats. Let's grep out MD5. We have MD5 crypt. And we have raw MD5, which is what we want. So we'll set the format to format equals raw MD5, and then we will give it the, is it the word list next? Dash dash word list equals, and we pass it the file. So dash dash word list equals, I'm going to put a space here just so I can autocomplete sec lists, passwords, probable top 1575, and then we're going to give it the hashes. I'm just going to go back here and make sure we don't have a space. Let's try that out. And you can see that very quickly got us the hashes. And use show dash dash show, and there you can get it to show you the hashes it found. Let's see what typically, to be honest, what I normally do rather than doing either of those things. As you can tell, I'm not really too clued in on the syntax there for John. Hashcat I would use a lot more, particularly for like when custom rules are needed and stuff. But we can go to CrackStation or an MD5 cracking service of your choice, and we can paste these in. And let's see if we get the other hash that we're missing here, because these have huge pre-computed they have huge lists of hash that are pre-computed from passwords. So unfortunately, sometimes we have to help them out with the machine learning algorithms. But okay, we'll let them off. You can see all the different types of hashes it supports, and here we go. We managed to get our 4 passwords. So we also got the password that it missed there, which was Charlie. Not really a hard password. We probably would have got that with a slightly better word list. And you can see here that their lookup tables were created by extracting every word from a Wikipedia database and adding it with every password list they could ever find. They also applied intelligent word mangling, so brute force hybrid, to a word list to make them much more effective. For MD and SHA-1 hashes, you have 190 gigabytes. 15 billion entry lookup tables, and for other hashes we have 19 gigabytes, 1.5 billion entry lookup tables. So this is really cool. You can download the CrackStation dictionaries here as well. I actually have one in, let's list user share word lists. Yeah, so I have CrackStation in here, have I been pwned one as well, and yeah, you can see the size of that. It's not as big as the have I been pwned one, but it's a good size. And that's just a little bit of bonus anyway for the password cracking. I hope you've enjoyed this video. Next we'll take a look at blind SQL injection.